Good morning, everyone. And this is our third Transmission Modernization Workgroup. Thank you for joining. I think, Emily, you're going to go ahead and pull up the agenda for today. All right, we're going to today focus on planning and siting transmission and distribution infrastructure as it relates to advanced transmission technologies. We'll also step through some of the new legislation that was enacted this session and get some of the perspectives from the implementing agencies. Then we will, after the break, hear from Lawrence Berkeley National Laboratory about their regulatory sandbox tool. And we'll, of course, take role by organization. If you're new to representing the organization, go ahead and introduce yourself. We'll go ahead and get that done right now. Attendance might be a little bit light. The PJM SIFP process or meeting is on right now for reliability backstop mechanism, and I would imagine that some of us in that space are absent working on that. So, all right, we'll go ahead and run through everyone. Let's go ahead and start Governor's Office staff.
Hey, Safer Tool, Deputy Legislative Officer.
All right, Public Service Commission.
DeAndre Wilson, on behalf of the Maryland Public Service Commission.
Great.
Good morning, Sambrawit Derari. I go by Sambri, also from the Engineering Division of the PSC. Thanks.
And Ben Baker, Senior Commission Advisor.
Thank you all. Maryland Department of the Environment. I believe someone here, someone on MDE's team that shows up regularly has a conflict, so there might not be anyone here. All right. DNR.
Hi, Ginny Rogers, Power Plant Research Program.
Thank you. PJM, unless they're all at the SIFP.
Matt Bernstein with PJM's Governmental Services team is on.
Thank you. Thank you for making time. Exelon Utilities.
Hey, good morning. This is Robert May with Baltimore Gas and Electric Transmission Engineering. I'm not sure if Dave Weaver's joining or not. He asked me to join this specific meeting, though.
Yep. All right, Rob, are you going to be given the update when we get to it?
I believe so. Dave asked me if I could participate to provide technical support, so I think that's why I'm here.
Yep. All right, great. Thank you. SMECO.
Good morning. It's Damon Krieger for SMECO.
Thank you. OPC.
Yeah, we're part of Maryland government as well. OPC, Phil Sussler. Thanks.
Department of Transportation, State Highway Administration.
Good morning, everyone. This is Ray Morbeck, Deputy Chief Engineer with Maryland State Highway. Nicole will not be joining us today. She had a conflict, and I'm going to stick around as long as I can, but I've got a conflict around 12. I'm going to have to jump off for, unfortunately.
All right. Thank you.
And this is Darren Lovas, Chief of Environment and Sustainable Transportation in the Secretary's Office. And sorry you have me instead of Ray for the entire time.
That works. Happy to have anyone. Advanced Energy United.
Hi, this is Katie Metal, and I am the Maryland Policy Principal for AEU, and we're an industry association.
Okay. Johns Hopkins Rosie Institute. I think Yuri, I saw you on.
Yes, right. I'm here. Thank you, Ryan. And I know that my colleague Abe Silverman will be joining shortly.
Great. Thank you. Grid Strategies. All right. Maryland LCV.
Hey, good morning. Rebecca Rear. I'm the Director of Climate Policy and Justice at Maryland LCV.
All right, thank you. All right, so like last time, go ahead and start by having a look at the deliverables. And these are, of course, the deliverables from the executive order. We have those up on the screen now. So what we're doing today, right, is considering mechanisms for applicants to demonstrate how ATTs are evaluated in the planning and siting of new or upgraded transmission or distribution facilities. So it's everything basically highlighted there in yellow that we're going to be covering today. So this will be included in the same category of recommendations regarding GETs and ATTs as before. So now we're going to go to Shannon and share an update on the process for recommendations based on our discussion at the last meeting.
Good morning, just checking on an echo. This is Shannon Preedy with the Maryland Energy Administration, just giving a process update. At our last meeting, we heard from 2 national coalitions about state and federal incentives from AMP and WATT on GETs and ATTs and advanced conductors. We've decided to hold off and package kind of all of the ATT's recommendations across those financial siting and planning mechanisms rather than do them piecemeal, since they're interrelated. And we're slated to talk through benefits assessment next month with RMI and a couple more stakeholders. So once we get through those topics, we may draft kind of a straw man proposal and ask you all to rate recommendations in terms of priority, kind of impact, high, middle, low, and feasibility, and certainly welcome additional recommendations. That'll help us start to identify areas of consensus, understanding that they'll be tentative and may evolve over the course of our work and our public comment period this fall. So just wanted to check back on that. Thanks.
Thank you, Shannon. All right, so next we're going to hop over to BGE and wrap up our discussion from the last meeting. So I think in March, Zach with the AMP Coalition pointed to projects by Exelon as an example where dynamic line ratings and reconductoring with high performance conductors has been done in Maryland. I think David Weaver, who is the VP of Transmission Strategy for Exelon and member of the working group, wasn't able to make it. And so I think he followed up with BGE's transmission and substation team about their experience deploying ATTs. So you can go ahead and turn it over. I'm sorry, it was Robert, right, who we have on for that discussion? Yep. Okay.
Yeah, and you can call me Bob.
Okay.
Fine as well. Dave unfortunately did not make the meeting in March, so he and I were trying to catch up with what the specific ask was. Essentially, I just put together kind of our history on use of advanced conductors in the GETS space and kind of where we are current state. So I'm just going to kind of go through some of that history. If anybody has any questions, feel free to stop and interrupt me. But basically, our first application of advanced conductors on the BGE system was back in 2009. I was very early in the deployment of advanced conductors, kind of industry-wide. And it was a very niche application. It was for a specific clearance constraint that we were evaluating. So we actually deployed 2 different advanced conductors in that application. It was one on one circuit and one on the adjacent circuit to kind of evaluate their performance, their installation, sales support, technical support from the manufacturers, those sort of things. And then we got kind of quiet for a while with our deployments. We didn't have a ton of work going on at the time, so we didn't really have a need to evaluate a lot of things. But as our work started to creep up in the late teens, we got our first full circuit deployment in 2019. It was a short circuit tying 2 substations together of 3M's ACCR conductor. It was our first kind of full end-to-end installation for that project. Since then, of our 1,200 plus circuit miles of transmission, we now have 42.5 miles of advanced conductor deployed. We went kind of all in with the one technology from 2019 through 2022. And like I said, we have currently 42.5 miles deployed. So it's roughly 3.5% of our system is using advanced conductors today. The large majority is the ACCR technology. We have some ACSS deployed, and we have some which is trademarked by Southwire as their C7 conductor. It's a carbon core conductor made with 7 core strands. So we have a little bit of a couple of different types of advanced conductor on our system. I said we have 42.5 miles. By the end of this year, we'll have over 90 miles. We have 2 large reconductoring jobs going on right now, or 2 circuits in one project being reconducted right now. That'll put another 47 or 48 miles of advanced conductor on our system. So we'll have roughly 7.5% of our system will be advanced conductor by year end. We have several projects in the hopper where we are evaluating advanced conductor, or we have designed around advanced conductor to be used. I'm not going to get into the specifics right now because they are kind of forward looking, but we have another large chunk of advanced conductors coming down the pike. Some of it will be using ACCC, that's a CTC product, another carbon core product. We have ACSS being deployed on our system more routinely now as well. Exelon as a whole, we are heavily involved with the research that EPRI is doing on advanced conductors. We currently fund one of their baseline projects in overhead transmission space, specifically on advanced conductors. And we also fund a supplemental project evaluating a specific advanced conductor technology out there. So we are evaluating these. We have, I believe, not that it matters for Maryland, but ComEd, our sister utility in Exelon, has some test spans up of some new conductors they're evaluating in the field, as well as the work that EPRI is doing in the lab. I don't know that I have anything else I can really provide at this time, other than the background that we have so far. Certainly welcome to take questions. But in summary, we are using advanced conductor. We are evaluating it for projects moving forward. And I know you have it on the agenda, some of the new legislation that came out. We're going to be focusing on that as well with some of our upcoming projects.
Yeah, thank you so much, Bob. Does anyone have any questions? All right. Shannon.
Hi.
Hi.
Sorry about that. Thanks for the update. I believe it's EPRI has the Gets Set initiative. So glad that you've engaged with that organization. Wanted to learn if you've encountered some of the barriers this group has talked about, particularly around kind of training and use of some of the advanced technologies. Any kind of insights there? Thanks.
So specific to conductors, no, we haven't really encountered too many barriers. Most of the manufacturers are very willing to come and support installation training and maintenance training with both our internal crews and our contracted crews. They provide just about anything we'd ask for on the engineering and design front. So the manufacturers are definitely supportive of deployment. Obviously, they're trying to sell their product, so they're going to do just about anything they can to get it out there. Looking at other technologies, and you mentioned the Get Set initiative, I know we are participating in that as well. I am not the participant in it, so I don't know the specifics of it. But Exelon as a whole is participating in Get Set. We're looking at things, I guess on the engineering and design side, the other application would be dynamic line ratings and the deployment of those types of tools. We've been evaluating those as well. I know Pepco has a pilot test for some dynamic line rating equipment out there. Regarding barriers, I think the biggest barriers to deployment of dynamic line ratings, again, from my perspective, is going to be around the cybersecurity ends of things and integration into EMS and rolling up into PJM's operation side of things. But that said, it has been done. The door has been opened on that. So I think a lot of that is going to become easier as we continue to deploy this technology around the grid.
Great, thanks, and welcome any response from PJM around the rollout.
Dave. Okay, Rebecca.
Hi, thanks. And sorry if these questions are a little naive. Perhaps I'm less technically savvy than some of the other folks on the call. But I just wonder, when you're doing this work, is there any disruption in service? Like, do you know, sort of as you're upgrading existing lines, can you talk about from that side of things? That's one question. And then you mentioned about 7.5% of all the lines are now have some advanced conductoring. What's the potential, like, of the what's the potential total deployment of this technology? So my two questions.
To the second part of your question, that's going to be a little harder to kind of define around numbers. We have some reconductoring as well as some new projects in the forecast where we are going to be using advanced conductor. So the percentage is a little hard. It's not just that 1,200 original circuit miles. As we add, the denominator of that calculation will change a little bit. But we do have it on the horizon for several projects. So I can probably look into it and provide more specifics another time. To your first question around the disruption and potential for, I guess, customer impacts or load serving impacts for the deployment of these, it's very minimal. We do take circuit outages for reconductoring, but because the system is built around essentially an N-2 scenario where you can tolerate the loss of one asset, there's redundancy built into it. It does put us at a higher state of risk when we're doing that work, but the customer doesn't see anything at their end as far as outages are concerned from reconductoring, generally speaking.
And do you have cost estimates on sort of like what this saves ultimately? Because there's a upfront cost to installation, but on what time horizon are you looking on savings, and what, if you're translating this into bills, it's hard to communicate because it's potential cost savings, but yeah, how do you communicate that?
It's a very complicated thing to try and explain. Being on the engineering side, I'm very focused on the upfront costs. I'm not sure if it's been discussed as part of this group, but generally we're seeing advanced conductors are anywhere from 2 to 10 times the cost of a traditional conductor. Where you see a lot of the savings in reconductoring is the ability to use existing assets, potentially with some upgrades, lattice tower reinforcement rather than replacements. So there's a lot of opportunity to avoid costs from that perspective. And as long as the assets are in generally good health, you can get away with that. So we have some lattice tower work we're potentially reconductoring, and we're just doing upgrades on those structures rather than replacements. So the cost delta for the conductor is saved in not spending money down the road. It again, really hard to try and put numbers on that. Yeah.
No, I understand. I'm in public health, and that's what that's the constant difficulty in talking about cost savings or avoided dollars spent. So really appreciate that. Thank you.
You're welcome.
Yeah, that was really interesting. I guess I'm just sort of curious. I'll let Samri go first though. But
Thanks, Ryan. Thanks, Robert. I guess the 7.5%, is that an Exelon figure or just BGE? That's the first question. And then the second question is, can you speak about your process in terms of like what kind of projects are better candidates for advanced technology? Thanks.
So that number is just BGE. I don't have much exposure to what our other peer opcos have. I know they are using it here and there, but that is just BGE's numbers. I missed the second part of your question. I apologize.
No worries. The second question is the process of using advanced conductors or ATTs. Right. What kind of projects are better candidates, and what is your current process?
So it's definitely a back and forth conversation with our planning organization. So for any given project, planning will define kind of what the load transfer needs are. What rating do we need from point A to point B, and we'll work with them to evaluate whether the line's a candidate for reconductoring. I mentioned lattice towers before. Lattice towers have the flexibility of being upgraded, as opposed to a steel pole where it's pretty much pass fail. If it's overloaded from a new conductor, then you really have to replace the asset. So that's part of the evaluation. Are we working with a lattice tower line? Are we working with a steel pole line? We always try and run even the steel pole lines through the structural analysis tools that we and our contractors have available and see if they are capable of holding those new conductors. When we hit roadblocks there, that's when sometimes things have to change. We'll reevaluate what conductors we're looking at, or whether or not it's still a candidate for reconductoring, or if it's going to have to be a rebuild. Constructability is part of that evaluation as well. Do we even have the ability to get put new structures in where we might need them, or are we really kind of locked into reconductoring? Do we have to build a new line somewhere else? Generally, if it's a new line, we may evaluate advanced conductors, but the costs will tend to work out that traditional conductors have some advantages there. That's not to say that it's the only solution. There are a lot of different ways to build a new line, and a lot of that's done in that early stage of engineering.
Thanks, Robert.
You're welcome.
Are there any other questions? I just had a quick one for you, Bob. You said earlier it could cost as much as 2 to 10 times as much. Guess what accounts for that wide disparity in the cost range?
A lot of it comes down to the technology that's being used. Some of the cores are quite expensive. A lot of these manufacturers are generally producing a core for their conductor, and then they partner with other companies to strand the aluminum on the outside of that. So a lot of the cost is built around the core itself. And I'm assuming a lot of it is also some of the R&D that's baked into that, so that dollar per foot or dollar per mile, you're paying for some of that initial R&D as well. But it's the technology in the core.
Okay. Very interesting. All right. This is final calls. Anyone else have any questions for Bob? No. All right. Thank you. Thank you so much. It was very interesting.
Thank you. If it's okay, I'm going to stay on the line because I'm interested in the legislative update.
Yeah, absolutely. Stay on as long as you want.
Thank you.
All right. And yes, as Bob just said, we are going to hop over and talk a little bit about the Utility Relief Act, especially with the relevant transmission components of the bill. All right. So this is I think it's just a general update, some level setting. So, right, the Utility Relief Act reflects an alignment between the Moore-Miller administration and the Maryland General Assembly to protect Maryland families from rising energy costs. Legislation provides immediate energy bill relief, modernizes Maryland's grid, and addresses the growing energy demands of the emerging technology sector by increasing accountability for data center development. And some of that, of course, is also in tandem, especially with some of the developments that we're seeing at PJM during the SIFT process. Several provisions of the bill do address transmission modernization through siting and permitting and planning. And we'll go over some of those together right now. But before we do that, I do want to open it up to Safer Tool out of the governor's office, if you'd like to say anything about the bill.
Yeah, thanks, Ryan. Thanks everyone for being here today. So before this session, the governor, the Senate president, the speaker, all sort of kind of highlighted 4 different markers around energy landscape, energy policy this session, specifically the identifying of ways to address the supply demand issues by incentivizing more local generation, modernizing our existing infrastructure and grid, which a lot of you are doing Omen's work here, holding big companies, utilities, and data centers alike accountable, and then providing tangible relief to Marylanders who are struggling with rising cost of energy. So over the course of last 90-day session, a lot of conversations, debate, and discussion. The teams and entities work collaboratively to develop this Utility Relief Act that focuses on those 4 big and broad categories. Specifically for our transmission work group purposes, I want to highlight a few things from the bill that directly impacts all things transmission in terms of modernizing infrastructure and in terms of providing relief around transmission. So first one is, the bill, a provision of the bill mandates Maryland transmission owners and operators to join join PJM or local RTOs, thus eliminating the participation incentives for voluntary RTO membership. That is a huge win for Maryland families, and holding utility companies accountable with a back of the envelope math. It showcases roughly about $20 million annual savings for Maryland families. Specifically around modernizing infrastructure, there are some CPCN reforms around transmission lines, especially expanding the CPCN requirement for all transmission lines, including the underground transmission. Folks who have been paying close attention to Baltimore Peninsula will be very familiar with that process, the debate, and then ongoing conversations around that. I do want to give a shout out to our partners at Grid Strategies. Over the session, the General Assembly leadership as well as our office have worked closely with Grid Strategies to incorporate the inclusion of ATTs and GETs into our state's transmission projects. So Ryan and Team MEA will highlight major pieces of that. And then last but not least, the transmission owners and operators are required to file a congestion reports with PSC every 4 years. This will be the marker of identifying ATT areas where we can incorporate ATTs and GETs into our existing planning process. So that's another way for us to be more educated, more aware of where we are falling short as a state and where we have the biggest opportunities and the best return of investment. With that, I'll pass it to Team MEA, and then we'll be happy to be available for any questions.
Yep, thank you, Saif. And we will go ahead now and dive into some of those specifics. So I see, Emily, we're already on the next slide. Excellent. All right, so first of all, we do have some relevant definitions to go over. All right, so the bill modifies the definition of qualified generator lead line to mean a transmission line, and now any associated advanced transmission technology designed to carry or support carrying a voltage of over 69,000 volts. Next defines a new term, advanced transmission technologies, as grid enhancing technologies, high performance conductors, or storage as a transmission asset. Then grid enhancing technology is further defined to mean hardware or software that increases the capacity, efficiency, or reliability of existing transmission systems. The term includes a system that uses real-time or forecasted weather and operating conditions to determine the transfer capacity of transmission systems. 2, technology that modulates circuit impedance or other electrical properties to reroute power flows and relieve congestion. And 3, software that identifies switching configurations to reroute electricity and alleviate transmission constraints. The bill similarly defines high-performance conductors to mean conductors, including advanced steel core conductors, carbon fiber and composite core conductors, and superconductors that have a direct current electrical resistance that is at least 20% less than traditional aluminum conductor steel reinforced conductors, ACSR, or of a similar diameter. Storage as a transmission asset also is defined to be an energy storage facility that is 1, planned, operated, and recovers costs as a transmission facility that provides transmission services, including congestion relief, voltage support, power flow control, or stability under PJM's tariffs and applicable FERC orders. 2, is not dispatched for wholesale energy storage. And 3, is eligible for cost recovery and transmission rates. This is effectively the definition of storage as a transmission only, as described in a 2017 FERC policy statement. Next slide. All right, now we'll get into the CPCN stuff. And of course, anyone from the PSC or PPRP that need to chime in, by all means. All right, so we have the expansion of the CPCN requirements to all transmission lines. SAFE did mention this earlier, right? So the bill replaces references to overhead transmission lines with transmission lines in section 7-207 and 7-208 of the Maryland Public Utilities article. This means a person may not begin construction of an overhead or underground transmission line at 69 kV or higher without first obtaining a CPCN from the PSC. Previously, a person was only required to obtain a CPCN to construct an overhead transmission line. The bill establishes that requirements and authorizations related to the construction of overhead transmission lines, such as notifications to adjacent landowners and construction related to an existing overhead transmission line, are necessary to avoid an imminent safety hazard or reliability risk, instead apply to all transmission lines. Okay, next slide. All right, the bill also requires an applicant for a CPCN to build a transmission line to include in its application evidence the applicant considered as part of its internal planning process, any local, state, or federal transmission planning processes, and any PJM transmission planning processes. This provision lists a number of additional considerations, starting with alternatives to the proposed transmission line. Applicants must analyze whether using advanced transmission technologies will enhance the value of the new transmission line and lead to ratepayer value through efficiency and avoided costs, and also alternative routes. On the distribution side, applicants must include evidence that they considered modifications to one or more distribution systems in the state that are owned by the applicant or its affiliates that could avoid the need for the transmission line. Additionally, they must consider the cost to ratepayers, as well as resource adequacy and any other information PSC considers appropriate. This bill also requires the applicant to include an analysis of the route selection, including 1, the risk associated with the cost estimates, 2, cost containment efforts, 3, the construction schedule, 4, acquisition of land and rights of way, and 5, the applicant's plan to engage communities and stakeholders on proposed routes. Next slide. So the bill also specifies that the PSC may only take final action on a CPCN application for the construction of a new transmission line after due consideration of evidence that alternatives have been considered by the applicant in accordance with the requirements. Next slide. Yep. All right, so the reporting requirements. So the bill requires each owner or operator of a transmission line by this December 1st, and every 4 years after that to submit a report to the PSC. The report must identify areas of significant transmission congestion costs for the immediately preceding 3 years and any reasonably foreseeable transmission constraints for the 5 years following the date of the report, as well as the actual and projected costs to ratepayers as a result of past and future transmission congestion. Transmission owners must also report on the feasibility and cost of using alternative means of addressing transmission congestion. And that includes the use of ATTs and the economic, environmental, and social impacts of the alternatives, and describe the transmission line rating method used in their assessment. The reports should distinguish between regional and local or supplemental transmission constraints and propose an advanced transmission technology implementation plan where it's feasible to use them to address the areas of transmission congestion identified pursuant to these provisions. The reports must reference the PJM planning inputs used to support the congestion forecasts and the proposed advanced transmission technology implementation plan included in the report. So the PSC can adjust the reporting schedule and has to publish each report on its website within 45 days after receipt of the report. I think we might be missing a slide, but I will also talk about good cause waiver. So the bill also directs the PSC when determining whether to grant a good cause waiver from the CPCN requirement for the construction related to an existing transmission line, which now applies to both overhead and underground lines, to consider the cost of the construction on ratepayers, the impact of the construction on the environment, and any other matter the commission considers appropriate. So the bill also repeals a provision requiring the PSC to waive the CPCN requirement if the commission finds that the construction does not require, one, the person to obtain new real property or additional rights of way through eminent domain, or two, larger, higher structures to accommodate increased voltage or larger conductors. These requirements apply prospectively to CPCN applications submitted after July 1, 2026. So just to recap, the bill makes 5 siting related changes. 1, it replaces references to overhead transmission lines with transmission lines in the Public Utilities article, thereby expanding those provisions to underground transmission lines. 2, requires an applicant for a CPCN to include in its application evidence that the applicant considered as part of its internal planning process, specified transmission planning processes, as well as an analysis of the transmission line route selection. 3, repeal for construction related to existing transmission line, a provision that requires the PSC to waive the CPCN requirement under specified circumstances. 4, require the PSC to instead consider certain factors for granting a waiver for good cause from the CPCN requirement for construction related to an existing transmission line. And 5, establish reporting requirements for owners and operators of transmission lines. So the effective date is July 1, 2026, pretty close. And now I will go ahead and turn it over to Ben and DeAndre from the PSC to dive into any of the other distribution related sections.
Well, I think you covered the sections we were going to cover, Ryan. I don't think.
Sorry about that.
All good. So I'll probably be turning most of this over to DeAndre to talk through our current processes and where this may have an impact. But ultimately, we're still obviously waiting for the bill to be signed. But I think a lot of this, and this was explained to MEA earlier, will be figured out as we start working through CPCN processes, especially the requirement for them to include certain information within CPCN applications. And so I think that will be kind of touch and go on the first couple CPCN applications as those roll in. Obviously, we don't have specifics figured out. But outside of that, DeAndre, I know you put together a slide or two about existing processes.
Yeah. If I could share my screen here, I could give me 1 second.
We can see it.
You can see it?
Yes.
Yep.
Okay, great. So good morning, everyone. And thank you for the opportunity to present today. My name is DeAndre Wilson. I am the Assistant Chief Engineer for the Maryland Public Service Commission's Engineering Division. And as Ben has stated, today I'll just briefly walk you all through the Commission's current role in transmission siting and permitting and how that role is evolving in light of the Utility Relief Act, or House Bill 1532. Today, I'll just focus on the concept as stated in the agenda of a distribution nexus, which is increasingly important in connecting planning, interconnection, and siting decisions. So before the Utility Relief Act, transmission siting in Maryland was primarily governed by the Certificate of Public Convenience or Necessity, or CPCN, under the Public Utilities Article Section 7-207. For transmission lines above 69 kV, a CPCN is required, and the Commission evaluates several core factors, which include reliability, economics, environmental impacts, the need to meet future demand, and alternative routing options. Now, while this framework is comprehensive, it has historically focused on need and routing. It did not consistently require evaluation of distribution system conditions or non-wires alternatives as part of siting decisions, which becomes more important as the grid becomes more constrained and complex. In addition to a full CPCN review, there are waiver provisions under Section 7-207. In certain cases, particularly upgrades to existing lines that do not require new rights-of-way, eminent domain, or structural changes, the Commission is required to grant a mandatory waiver if statutory conditions were met. This structure limited opportunities to evaluate alternatives, broader system impacts, or cost considerations. As a result, there was less ability to consider grid optimization strategies or distribution level solutions as part of those siting related decisions. To address the broader system needs, the Commission established the Distribution System Planning Workgroup, which later evolved into Electric System Planning, or ESP, following legislative changes, including the Climate Solutions Now Act and House Bill 1393. COMAR 20.50.15 now requires integrated transmission and distribution planning and the identification of non-wire solutions to address system constraints. From a siting and permitting perspective, ESP plays an important role. It provides feeder and substation level visibility, helps identify localized constraints, and supports more grid-informed siting decisions. In that sense, ESP can provide the underlying data needed to align project location with actual grid capability. Now, in regards to a distribution nexus, when we refer to distribution nexus, what I interpret, or what is interpreted, is about the relationship between a project's location and the electric distribution system. This includes how and where a project connects to feeders, substations, and local circuits, as well as whether there is available capacity, existing constraints, or a need for upgrades. This is important because a project can be well sited from a land use or environmental perspective, but still be located in a part of the system that is constrained. When distribution nexus is not considered, it can lead to higher upgrade costs, longer interconnection timelines, and inefficient siting decisions, which ultimately could impact ratepayers. This concept is supported by the Commission's ESP framework, as well as broader policy direction reflected in HB 1532 and the governor's executive orders, which focus on site readiness and grid optimization. At a high level, distribution nexus can help bridge planning, interconnection, and siting decisions. The Utility Relief Act introduces several changes and clarifications to the CPCN process, as Ryan has stated earlier. It expands applicability to both overhead and underground transmission lines and increases the expectations for alternatives analysis as part of CPCN review. Importantly, it requires evaluation of advanced transmission technologies and consideration of distribution system conditions and alternatives, what we've referred to as the distribution nexus. This includes assessing whether localized constraints can be addressed through non-transmission solutions. The Act also encourages greater integration of planning, siting, and interconnection processes, updates the waiver structure by making it discretionary rather than mandatory, and adds considerations related to public interest and ratepayer impacts. Overall, these changes move siting and permitting towards a more grid-informed, cost-conscious, and integrated planning framework. In closing, siting and permitting decisions are increasingly informed by distribution system conditions, helping align project location with grid capability, cost efficiency, and reliability. What this reflects is a broader shift toward aligning where we build with how the grid can support it, which is critical to achieving the affordability, reliability, and deployment goals outlined in the executive order. So I thank you again for this opportunity, and we are happy to answer any questions.
Thank you, DeAndre. Does anyone have any questions for DeAndre? Any questions? Any questions at all about the legislation or anything that we've gone over in this section? All right. All right. So there are no questions. It's 11:52 now. Let's go ahead and start the break a couple minutes early. We'll come back at noon and we will get started with LBNL. And we'll see you then. All right, everyone, go ahead and get started. I'm back. Hopefully, a little bit of a breather there. All right. So, in January, the Lawrence Berkeley National Laboratory announced a new toolkit and technical assistance that's available for states and utilities on regulatory sandbox design and implementation for advanced grid technologies. Berkeley Lab is a U.S. Department of Energy Office of Science Research and Development center managed by the University of California. Regulatory sandboxes offer a structured environment for testing advanced grid technologies and new business approaches under modified rules to increase the speed of adoption. We've talked about how advanced grid technologies are important to enable transmission and distribution systems to meet growing demand. However, traditional regulatory processes typically lag technological advancements. Regulatory sandboxes aim to bridge this gap. Our guest, Grace Relf, is a policy researcher in the Energy Markets and Planning Department at LBNL. She conducts technical, economic, and policy analysis of energy topics centered on the U.S. electricity sector, including focuses on electric system planning, utility programs and regulation, and grid edge resources. Prior to joining the Berkeley Lab, Grace acted as the Chief of Policy and Research at the Hawaii Public Utilities Commission, where she led development of electric utility performance-based regulatory frameworks, next generation grid edge resource programs, and resource procurement processes. She is joined by her colleague, Josh Ryer, Principal for the Northeast region with the Regulatory Assistance Project. And whenever you're ready, you can go ahead and get started.
Great. Thank you so much for the introduction. Let me pull up the slides. Okay. You're all seeing the slides well? Okay, great.
Yep, you're good.
Well, that was a great introduction. Yeah, thank you very much for having us. I'm Grace Relf. I'm here with Josh Ryer, and we're excited to present to your group and discuss with you all the tool regulatory sandboxes and how they might serve your objectives here in Maryland. And we encourage this to be a discussion. So if you have questions, please do raise your hand or feel free to jump in. We'll be happy to answer questions as we go or at the end. So this presentation, this discussion is intended to provide you all with more information on what regulatory sandboxes are, how they work, what challenges they are helpful for, and best practices for establishing and implementing a sandbox. And then we really want to offer some perspectives on how they might support your specific objectives laid out in executive orders and in legislation, and basically provide you some food for thought going forward, and get you all thinking about whether this is a tool that might be useful for your context. We're going to go over why you might use a regulatory sandbox. So what are some barriers to utility innovation? How do regulatory sandboxes help address those barriers? And how can you design and implement them well? And then how can we design them specifically to facilitate specific desired outcomes, like supporting deployment and scaling of advanced transmission technologies, or ATTs, and talk through some considerations for Maryland specifically. Josh and I are going to tag team this a little bit, so I'm going to hand it over to him for the moment.
Great. Well, thanks so much, Grace, and thank you all for having us today. Like Grace and Ryan said, my name's Josh Ryer. I'm the principal at the Regulatory Assistance Project, or RAP, for the Northeast. I actually just recently joined. I'm coming from Massachusetts, where I was Assistant Secretary of Energy. And then before then, I spent 5 years at the Connecticut Commission. So in both those jurisdictions, had the opportunity to work on regulatory sandboxes. We can go to the next slide. Great. So, as we talked about, there's, we want to give you level set on, why this is an emerging best practice and something that we're seeing in other states start to think about. And I think this group knows that, load growth, aging assets, grid energy or distributed generation, load growth, particularly in light of kind of electrification goals, more frequent and severe storms. We're really seeing that more and more is being asked of our electric utilities, whether they're transmission companies or distribution companies. We're asking them to update their grid planning processes, to expand the infrastructure that they have in place, to improve asset management, expand resilience programs, a whole list of things. We capture some here, and certainly there's more. But also, as you can see on the right from a recent paper, we're also seeing that technology innovation is outstripping regulatory innovation. So regulatory sandboxes are one tool to help bridge that gap between the pace of innovation and changes in the technology space and the need to really be able to meet the moment on the regulatory and utility front. So next slide. Great. So there's a few reasons for kind of the disconnect between the pace of change and innovation in the utility and regulatory space compared with technology adoption. The first is simply for the better part of the last 100 plus years, we've really been asking the utilities and our regulators to first and foremost to ensure the safe and reliable operation of the grid. And that encourages, frankly, small c conservatism, there we go, and risk aversion in some decision making, or it can, not always, but it can. And that often can come into play with thinking around innovation. There's also other kind of disconnects between innovation and the regulatory and utility business model. I think we all know just the pace of change of innovation compared with the regulatory and utility business model. There can be a disconnect there. And we've seen this result in smaller R&D budgets for utilities compared to other industries. I think there's plenty of research out there on that. We also see this result in the proliferation of a lot of one-off pilots, and also an infrequent scaling of those pilots. And so you can see here, there's a number of different barriers that are identified here. Certainly, capital bias can be one. The length of regulatory processes to approve novel approaches can be another. And as I already mentioned, fear of technology risk is also a big one that can play into, and again, can be part of the disconnect between the current utility business models and regulatory framework and an approach that encourages innovation. Next slide. Great. Also, I'm sure this group is familiar that there's
Josh?
Yes.
I got a quick question.
Please.
Maybe you're going to go into this later, but do you have any examples of the capital bias that you had on the last screen?
Sure, I can talk about that a little bit. I mean, in general, and I was just actually on a call before this talking about this with some of my colleagues. As I think most people on this call probably know, that utilities earn a rate of return or return on equity in their investments in capital solutions, and they don't usually receive that return on equity for other solutions that are usually O&M expenses or pass-through costs. So in order to kind of increase their company's profit, they usually focus on capital-intensive solutions like poles and wires. So that's kind of the business model question. And I think we see this. I think one example is, for example, on CEO investor earnings calls, you never hear anyone talk about the number of solar and storage projects that were deployed to avoid a grid upgrade, but you hear certainly about the capital that has been deployed and the profit on that capital. So I think it's really a structural thing that we see. Hopefully that answers your question.
Great, thank you.
Yep. Great. So and I'm sure again, folks on this call are familiar with pilots and some of the pros and cons of the pilot approach. And just to highlight a few of kind of the problems that you can see, or some of the barriers we see to really large scale adoption of pilots, is often there can be unclear terminology or even unclear goals with what a pilot's trying to achieve. There also rarely is a pre-identified process for actually scaling a pilot, right? Often we see a pilot saying, let's try this out, or this is a good one-off, but rarely is there identified ahead of time a process for actually scaling that pilot to be able to be used by more individuals. There's also rarely an opportunity, or there can be a lack of processes to actually share learnings out of pilots. So all of these things kind of come together and create an environment where sometimes there can be a lack of ability to actually scale pilots. So sandboxes are really fundamentally a different approach. It's not just looking to test one-off solutions, but rather as an approach to really change how and modify how existing processes, rules, and regulations operate in order to test new ideas. And often they're designed explicitly with expectations around data gathering, data sharing, and as well as scaling. Next slide. All right, so just to get a little bit more specific about that last point. So regulatory sandboxes are a structured environment that allow for the utilities and stakeholders to test out either new technologies or new approaches with customers and businesses and within the utility to try out existing technologies. So really it's a way to test out multiple different approaches or different projects potentially that are either, again, testing new technologies or new ways of applying existing technologies. So a good example of this, and Grace will talk about this a little bit more later, is the Connecticut Innovative Energy Solutions Sandbox mechanism that allows for and solicits annually cutting-edge proposals to run a trial for 12 to 8 months before assessing the results and quickly determining whether or not that pilot actually should be scaled up and provide benefits to all customers at a broader scale. Next slide. And then just quickly, in addition to that outcome, just wanted to highlight, I really want to make sure that the point is clear that a sandbox isn't just a one-off pilot, but rather it's a comprehensive approach to allow for multiple pilots to be tested quickly and to see if they're eligible and really ready to be scaled. The Vermont Innovative Pilot Program Sandbox mechanism really tested a number of different pilots, from a resilience zone, fast charging. Folks might have heard of the Vermont Bring Your Own Energy Storage Device program, which has been incredibly successful. They've also tested flexible load management programs. So again, a lot of different types of pilots have been tested through the Vermont Sandbox, and many of them continue to live on because they were successful through that mechanism. Right, next slide, and I think we're going to turn it over to Grace.
Yeah, great. So wanted to provide some additional examples of specific sandboxes that we've identified through our research. So Josh mentioned the Connecticut Innovative Energy Solutions Program. This is a sandbox that allows utilities, innovators, and collaborative partnerships between utilities and third-party innovators to propose new programs and technology trials. This, the IES program uses thematic calls for proposals, and they also have an innovation advisory council that helps to select a group of those ideas that ultimately get approved by the regulatory authority. This program is somewhat unique in that non-utilities can propose ideas, which helps to get new and more ideas on the table. As part of the New York Reforming the Energy Vision initiative, they had an explicit focus on innovation through what they called innovation sprints and demonstration projects, or demos. The demos were really intended to trial new revenue models and partnerships for the utilities to help build value for customers and quickly scale those. In Hawaii, as we were developing the performance-based regulation framework here, we developed an innovative pilot framework. Part of this was recognizing that the performance-based regulation framework was going to be built with cost control measures in place, which potentially could limit innovation. So we developed this framework that carves out funding and provides expedited review of proposals. Any pilot that's proposed through this gets reviewed within 45 days, which in the regulatory space is pretty lightning speed. Sandboxes really, I think, in the US, we've largely taken our ideas for these sandboxes from abroad. These examples all place a particular emphasis on going beyond just demonstrating technical feasibility of different technologies, but really testing new regulatory models and overcoming regulatory barriers to innovation. So in the UK, Ofgem, the Office of Gas and Electricity Markets, developed a sandbox also as part of their PBR framework. They focus on relaxing, modifying, or removing specific rules or regulations for a shorter period of time to support innovations. Ontario similarly has a sandbox that has a strong focus on providing direct support to industry innovators. So those companies and organizations can actually connect directly with regulatory staff, and those staff will help innovators understand the regulatory landscape and how their innovation might fit in there. They've also had some interesting competition type calls for proposals that have increased engagement with the sandbox with funding tied to them. Singapore also formalized a sandbox in 2017. They found that they were issuing a number of ad hoc exemptions to regulations in the name of innovation and wanted to sort of formalize that into a longer, more sustainable program. And these examples have really been foundational to what we've developed in the US. I want to just be clear though, regulatory sandboxes do not address every barrier to innovation. They're not like a silver bullet to increasing adoption of these technologies or to promoting innovation. And I like to encourage thinking about an ecosystem of innovation and how you could deploy multiple innovation vehicles and create sort of like a whole holistic environment that supports innovation within your state. So innovators are going to want to be somewhere where there is at least some demand for their product or service, so they can confidently invest in development. And having multiple pathways to scaling or adoption or testing can be helpful for innovators to feel that confidence. A number of innovation vehicles exist to help do this. Common ones that we've seen include PBR frameworks, policy directives, or vision statements. So that's sort of like the state, maybe the governor's office or the Public Utilities Commission issuing a statement that they'd like to support innovation explicitly. And then information sharing platforms. So trying to get the message out about what innovations have been successful, connecting innovators with utilities or other buyers of potential innovations, those kinds of things. These are some of the other innovation vehicles that we've identified. So at the utilities can invest in research and development or demonstrations or pilot programs, can also sort of organize themselves in a way that focuses on innovation. So maybe hiring an innovation officer or something like that. There are legal and regulatory driven approaches. So opening a topical or information gathering proceeding at a Public Utilities Commission to identify what different technologies are out there. I also like the idea of direct changes to policies or utility regulations. I think a really interesting idea to just overcome utility barriers to innovation is just, is there a barrier and can we remove it? Pretty simple. And then the track then act approach is also a pretty simple one. Can we watch what other jurisdictions or utilities are doing, learn from them, and act more quickly without having to test it ourselves? And then some of these more economy-wide or broader approaches are things like providing grants or financing to innovators through an innovation hub or an incubator, having like a pitch fest where you're bringing your innovators in to a room with investors, or things like technical assistance as well. So maybe I'll pause there. Yeah, go ahead.
I was just going to add too, and obviously very interested to hear if there's any questions from folks. But I can speak a little bit to the Connecticut Innovative Energy Solutions program that I was part of helping to stand up. One of the things on Grace's broader point of creating this ecosystem of innovation, that was really the idea behind us standing up an advisory council. In Connecticut, there's a kind of quasi-public venture arm that got its seed funding from the state called Connecticut Innovations. There's a green bank. And so sometimes, at least we had received the feedback that innovators didn't exactly know where to go in Connecticut, and it could feel kind of disjointed. And we also wanted to create kind of this collaborative environment where innovators in Connecticut or kind of in the tri-state area had really felt like they had a sense of purpose and kind of were included in the process. So it was really important for us in Connecticut when we were designing that program to set up that council to get buy-in and to make sure there was a clear and comprehensive approach to innovation in Connecticut.
Thanks, Josh. That's helpful. I was just going to pause and see if there were any questions. Like, is the definition of a sandbox clear? I know there can be a little wishy-washy. We've taken definitely a broad thinking on how we're defining sandboxes, but just pause for 1 second. Okay, hearing none. Wanted to talk a little bit about how to effectively design and implement a sandbox. So there are many design elements of sandboxes. Major elements include the scope. So what are your objectives? What are the activities that you want to include? What derogations are allowed? A derogation is basically a modification to an existing rule or regulation. And how much funding is available and where is that funding come from? Once you've kind of scoped it, then you get into the participation requirements, which is maybe the more specific elements of how innovators will apply and get selected. And then finally, how will the trials be evaluated, scaled, and communicated to the world? Those are kind of the governance and oversight systems at the end there. We have found that sandboxes can be structured in multiple different ways. We reviewed the landscape of sandboxes out there in the US, and we grouped them into these kind of 4 common types. The first are what we're calling funding opportunities, which carves out a specific pool of funding for innovative projects. These act more like a grant mechanism where projects are awarded funding if they meet selection or eligibility criteria. And what makes this a sandbox, or like the deviation from traditional regulation, is that there is pre-identified funding available. So in the typical utility business model, a utility would have to apply for funding and get it approved by the regulator, or at least in a review, have it be determined that it was prudently spent. Pilot processes are aiming to modify how utilities have to typically run their pilots to help sure that we are creating learning and that successful trials can scale. So for example, this might look like an expedited review timeline or providing more certainty around cost recovery than for traditional regulatory review of pilot applications. The deviation here is typically that the review period is very sped up, so 45 or 90 days, or even no review at all by the commission. In some cases, we see that utility commissions are using rate cases or rulemakings to advance innovation to establish a sandbox mechanism, such as through a multi-year rate plan or something like that. And finally, a more regulatory sandbox would include some specific derogation to rules or regulations. These usually focus more on testing new regulatory regimes or business models that can promote innovation, rather than on testing specific technologies or programs. But through our research, we found 15 examples of sandbox type mechanisms, 12 of which were adopted and still in effect today. There's a nice mix of sandbox types, good geographic diversity of states that are using them. And this data is actually even a little outdated. I know there are at least 1 or 2 more that have been established in the last year. So we really do need to update this map, but I think it's helpful to see that, this is an approach being used across the country. Josh, I think this is you.
Yeah, great. Well, so like any new approach, it comes with potential benefits and potential challenges or risks. On the benefit side of things, I mean, testing new technologies, particularly if you have a focus on new grid tech and advanced transmission technologies, certainly can have the upside of improving grid reliability and resilience. It also can potentially improve economic outcomes. I think we heard the discussion earlier of some advanced conductoring is 2 to 10 times more expensive, but if that defers an upgrade or avoids an upgrade, that would be 20 times more expensive. Of course, there's potential economic benefits there. It also is, if you structure it in a way that is transparent and provides learnings from these pilots, whether they're successful or not, it actually can provide learnings for other innovators, other utilities in the space, your policymakers, to better understand pros and cons of different solutions and to help you be successful in the future. And of course, it can also just help advance innovation, so encourage new thinking and new ideas where maybe traditional thinking isn't actually achieving currently the state's or the utilities' objectives. Again, with any new approach to things that comes with risk, it does take time and effort to stand up a new approach. And I'm sure particularly the state's employees on the line know that there's always more that's asked of you and not necessarily more resources that are provided, but it can long-term provide, like I said, those benefits. And there are ways that we'll talk about in a second to minimize the additional cost and time spent in standing these things up. And actually, ultimately, if you're already testing pilots, ways to make sure that you're getting more out of the pilots and are just more effective with your approach to using pilots or demonstrations to try and get at and achieve some of those grid and economic benefits. There's also, if you don't, design this appropriately and work directly with your utilities, there's the potential for new approaches to have impacts on the grid. There's, of course, with any pilots or any kind of thing that you're testing that needs money to be tested, there's the potential for an economic impact through rates and other negative consequences for customers. And then, of course, if you're preferencing any type of solution or innovators, there is the potential for market distortions that can have an impact on other solutions providers that if not addressed could be unfair to those technology and solutions providers. So next slide.
Hey, Josh, on that one right there, the
Yeah, please go ahead.
Yeah, do you have any? Have you seen that in any of the sandboxes that you've done?
The market distortion part.
Yeah.
No, honestly, I haven't seen that, and I'm curious if Grace, you have any examples of that. I think at least from my perspective, I think it's important to highlight that if you're designing this, you want it to be fair and open, and you don't want, and we'll get into the next slide, you still want to be technology neutral. I would say that the traditional solutions have such, for lack of a better word, advantage, right? We know how to deploy them. There's very clear paths to implementation there. So I haven't really seen any examples where it's pushed aside, a sandbox has pushed aside those traditional solutions where they're just clearly the answer. But again, we at least wanted to highlight as a potential negative outcome. I don't know, Grace, do you have any examples of that?
No specific examples of like a market distortion, but I think the idea is like, if something is truly innovative, there's likely to be only like a single vendor that is offering that solution. And so potentially you're maybe closing out other vendors that might have a similar solution or something like that. But there are ways around it. So like I'll offer that in Vermont, they have an interesting model where anytime the utility is proposing a pilot that they would own and operate assets, they also run a similar one where a third party would own and operate the assets.
Yeah.
So it's sort of intended to overcome some of those market distortions. And one other point here that I think is a challenge is like, once you've kind of proven that a technology is good, like through the pilot that you've run, then how do you scale it? Are you still able to go through that one single vendor? And I think it's important to be thoughtful about like, at that point, do we need to then go out to the market and see if others can offer the same solution at a lower price or more effectively? So yeah, that's, I think, the intent there, but lots of ways to mitigate those risks.
Yeah, thanks, Grace. That's helpful. Yeah.
Great. Well, and so just getting into some more of those tactics to kind of mitigate some of these risks. So as I mentioned, standing up a sandbox takes time and effort, and certainly, ensuring the success of pilots, tracking those pilots, scaling them up can take time and resources. But there are ways to minimize the time and effort, particularly if you put it in upfront to design the program well. And again, this all should be taken as in comparison to the current approach to pilots. So, for example, in Connecticut, we had a process for standing up pilots that was not particularly effective. So actually, a sandbox, when compared to that, it saved us time on the back end in standing that up. But to get into some of these specific risk mitigation tactics, you just want to make sure one of the key best practices is making sure there's flexibility to adjust projects in real time, and frankly to even to use the kind of Silicon Valley approach to fail fast with some of these projects if it's clear that they're not delivering on their potential benefits that they claimed. Being able to say that we're not going to continue to fund this project is something, at least in Connecticut, that was really important, and again helps reduce the amount of time you might be using on a project that ultimately isn't going to be successful. Also, making sure that you're incorporating learnings on the framework and the sandbox over time. And that really you think at the outset, but over time, whether or not a sandbox is really addressing the core barriers or the outcomes that you're looking for. A sandbox isn't the right solution for every challenge or barrier that's out there, but it can be in several instances. So just making sure at the outset, and as time evolves, whether or not a sandbox is actually the right tool to address the barriers that you're trying to address. I already mentioned in terms of negative impacts to the grid that really the key here is to have a real partnership with the utilities early on to make sure that you're understanding any technical implications of the technology, as well as just to incorporate kind of clear eligibility requirements early on to make sure that, again, you have safeguards up front that any technology or new approach to deploying a novel technology will not have grid implications. In terms of negative customer impacts, and again, particularly thinking about the potential costs of a sandbox or new pilots, talked to some of these earlier, but just to be really clear, some other things that you can implement are clear project or sandbox wide budgets. So for example, the IES program in Connecticut has an annual budget, as well as implementing project caps as well, budgets. Also, one thing that, again, the IES program has, and we've seen as kind of a emerging best practice, is making sure that there's a plan for the pilot to actually be able to scale if it's successful. And they're not just planning to be a one-off solution, but really can scale and have that impact at scale over time. And then I mentioned earlier the ability to kind of fail fast and to cut off a project earlier in the cycle if it's not successful. One approach that we're seeing is that that's actually built into the contract between the utility or whomever else is actually providing compensation, that there's clear project milestones that at least balance the need for innovators to have some capital outlay, to have the money to be able to try this out, but also that if they're not performing, that they don't continue to receive money for the project. And then, as we talked about earlier on market distortions, just making sure that the design maintains technology neutrality, and that there's transparent eligibility criteria and objectives and selection criteria, so that it's clear out front to everybody what is expected, and that you're really focusing on outcomes and like the actual qualities of the solution that you're looking for, and not the specific technology.
Great. Yeah, and a lot of these are emerging best practices, those risk mitigation tactics. But we identified a whole list of emerging best practices for designing and implementing a sandbox. So for example, when you're starting your sandbox, you want to start with a good sense of what is actually hindering innovation in your jurisdiction so you can build around that. And we heard, I did a bunch of interviews for this research, and we heard across the board that it's really important to have strong buy-in from leadership at a number of parties and entities that are going to be involved in this. And then also, having that advisory group can be really helpful in bringing expertise in new areas that might, that might not be as prevalent at the existing organizations, or, that might be more helpful from external folks. You also want to consider how to actually design it. Requires thinking through issues like who can participate, how do you evaluate proposals, those kinds of things. And then I wanted to just note too a couple of administrative best practices. So having a very clear calendar of events, dedicating enough resources to make sure that you can actually follow through with your plan, and communicating publicly around the sandbox. When you get the word out there about this opportunity, you get more good, innovative ideas, and maybe allow other folks to bring ideas to the table rather than having, the utility or transmission owners as sole gatekeepers to innovation in that space. So encourage you to check out the full checklist there. Okay, wanted to talk a little bit about how to facilitate specific outcomes with sandboxes. So you can design sandboxes to support specific outcomes like advancing affordability or supporting ATTs. So some of the approaches that we see out in the field are using thematic program cycles to encourage applications in specific areas. So this has been done in Connecticut, where they've used themes like demand side flexibility. And I think the most recent theme is residential energy affordability. You can also design your eligibility and assessment criteria to reward specific outcomes. So in Washington, D.C., they have a whole scoring spreadsheet that allows them to weight specific screening criteria to score applications and have those that rise to the top most aligned with what they want to see as outcomes. As I just mentioned to you, you can have advisory councils designed to supplement the expertise of your agency or folks who are reviewing applications. So if you need expertise in financing or maybe, specific ATT expertise, that could be something that you bring in from the outside. I also just wanted to mention this. I know that one of the things in the executive order in Maryland has been considering shared savings mechanisms. And I think that it could be a really interesting approach to sort of use a sandbox to test out SSM designs and see how that works in practice and whether you're actually able to implement those SSMs or maybe different performance incentive mechanism designs. So I wanted to provide some specific examples of, how we've seen sandboxes support transmission technology deployment. So Pacific Gas and Electric in California ran a speed to power trial, or it's ongoing actually, where they're looking to energize large load customers prior to completing transmission upgrades. And this is sort of a phased, flexible service agreement with curtailment on PG&E's signal. And so the pilot is supporting PG&E's development of a heat map of how long and how frequently they expect to have to curtail loads. And then they're using a new transmission energy management system to help with forecasting and then that signaling for curtailment as well. So I think this is just one example of a transmission technology program that has run through a sandbox. There are many, many more.
Grace?
Yeah, go ahead, Ryan.
Sorry, yeah, quick question on that. When did that start?
That one, I believe, started in 2025, so pretty recent, but I would need to go back and look. That link there should take you directly to the page where it where it's listed.
Yeah, all right, thanks.
Yeah, you're most welcome. In the UK, I think we noted again that the sandbox there is part of their innovation, or excuse me, their PBR framework, which is called RIO, Revenue Equals Incentives plus Innovation plus Outputs. And I say that just to mention that innovation was a very specific goal of this model at the outset. So you can see it's a big part of this. And when they reviewed the RIO, when they were reviewing the predecessor to RIO, they found that it was disincentivizing innovation because they were really focusing on operating cost efficiency that was looking at near-term solutions and not looking kind of longer-term thinking and investments to reduce costs in the longer term. And so the more recent version of RIO includes multiple innovation mechanisms They have stimulus funding for innovation projects. They have expedited review of innovation programs and a more specific regulatory sandbox as well. And these are just a couple of examples of the National Grid's transmission projects that they've run through the National Innovation Allowance program. They had in 2025, 95 different transmission projects that were live and ongoing. And then on the right here, this is just some examples of what those projects are. So I think they've got some robot and AI programs that they're doing. They've got DC connections that they're testing. They're also doing some promotion of or testing of power flow control solutions. So a wide range of different solutions that they're testing through these innovation programs in the RIO model. Okay, so just wrapping up here, wanted to mention that we do have a number of resources on this. So our research that we published last summer is available, and it provides kind of an overview of all that we've presented today in much more detail. And then we also have a toolkit available, and there are some downloadable resources that I encourage you to take a look at, and you can find a library of project examples that you can filter based on what kind of technologies you might be interested. So definitely take a look at that. And let me know if you have any questions about it. And then just to wrap up here, so some of the findings from our research was cataloging the types of mechanisms and identifying those emerging best practices for designing and implementing them. Importantly, the folks that we interviewed for this project overwhelmingly felt that they've been successful for many reasons, not just because you're able to test new technologies, but also because sandboxes help to create a culture of learning and innovation that they thought had spillover effects within utilities and regulatory agencies and more broadly. So as one example, I thought that was interesting. One of our utility interviewees noted they were getting a lot of good ideas for pilot projects. Not all of them were appropriate for the sandbox or able to move forward that way, but they were able to direct those pilot ideas or project ideas to different areas of the utility and have them move forward in that way. So lots of spillover learning effects there. There are areas where, yeah, go ahead,
sorry,
Jack.
I was just going to add real quick on just to one plus that concepts. I would just say both from my time in Massachusetts and Connecticut, you don't know what you don't know, right? And we all, these type of working groups, conferences are a great way for everyone to find out kind of what's the new innovative way of thinking about things, what are the new solutions, but actually having a systemic approach to having all of those ideas come to you and be able to evaluate those, I found very valuable in both states because you don't know what you don't know, and often you're sitting there trying to find a solution to something that seems unsolvable, and yet you don't know what innovators are already trying to solve, and they probably have seen that solution as well, seen that problem as well, and so they may be actively working on something that can solve that problem. And certainly there are many cases in Connecticut where there's projects and solutions that came to us that I had no idea existed. And so just having that place to be able to learn and see what's out there was also incredibly valuable.
Yeah, absolutely. I totally agree with that. And then I did want to mention there are a couple of ways that I think we can still be improving on these sandbox designs to increase the impact. So one, placing a stronger emphasis on trialing advanced grid technologies. I think we know that these technologies have a lot of possibility. If we can make sure that they work specifically in our jurisdiction and in our unique circumstances quickly, we can scale those up much faster. And I think too, we see that scaling is still an area where there are some challenges and where we need to have an explicit focus on figuring out how to do that more quickly and more effectively. Some jurisdictions are doing it really well, and I think there is a lot of learnings to be had there. I wanted to offer, I pulled out some of the objectives from the executive orders that you all are working towards, and I just had a couple of thoughts on how a sandbox might be able to help here. So one of the objectives was demonstrating how ATTs are evaluated and then providing transparent justifications when you're not selecting an ATT. So trials through sandboxes are really helpful for information gathering and having clear reporting and metrics to help support reporting going forward. You're also able to gather that real world experience and help you identify where can we best deploy these quickly, how can we best prioritize our many opportunities in front of us. You can also identify a process for selecting candidate projects. Similarly to above, like the data from these trials can help you identify selection criteria or what you need to know before moving forward with a project. As I mentioned before, I think there are multiple ways that a sandbox could help you with your shared savings mechanisms or performance incentive mechanisms. One, you're collecting baseline data with which to calculate savings levels. So you're actually collecting information on costs and benefits and having a more of a baseline from which to assess avoided costs, which is a challenging part of SSM design. And then you could also actually trial specific SSM designs within the sandbox as well. I also noticed there was some language around fast track permitting. I think that came up earlier in the meeting, but sandboxes are explicitly designed to support faster workflows and identify the appropriate circumstances for modifications to regulation. So I know one of the pieces there is identifying when a waiver is appropriate. I think this could be helpful for identifying when those waivers are appropriate and issuing them in a more systematic way. And then finally, I noted that there was some conversation in the EO about regulatory de-risking. I know this was more in reference to power plant siting, and I do, from my understanding, it seems like there is some consulting services being offered on power plant siting. But I just thought this was an interesting piece because a number of sandbox designs out there in the world include those types of consulting services that help you pre-vet projects and really get the best ideas coming forward to help kind of reduce regulatory or administrative burden once you do get those projects on the table. Just some closing thoughts here. I think it's helpful, one, to explicitly identify the unique aspects of your transmission contacts that are hindering or promoting innovation. Can we elevate those that are promoting innovation? And what can we do to overcome those barriers that are maybe hindering innovation in our jurisdiction? I think you'll want to also start with like a baseline understanding of what our utilities and transmission owners are already doing in terms of research and development, pilot approaches, budgets, and what has been successful. I think, hearing from the Exelon utilities earlier is a helpful start, but I think, collecting even more information would be helpful. And then you can evaluate how those historical pilot projects have gone and what have been successful projects or challenges. One thing I want to offer here is that when you have better information sharing practices, you're better able to assess, oh, we actually don't need to pilot this. We already have the information we need to say, yes, that this can go forward without a pilot. We're ready to do maybe more of a phased rollout or just move forward with a full-scale program if we have good data on it. And then, of course, you want to solicit ideas and perspectives from this group and additional external stakeholders where necessary on what they see as opportunities for innovation and areas to scale ATTs. And then, we'd love to help you consider whether a sandbox is appropriate in Maryland or develop a specific proposal if you all think this is a recommendation that you would want to put forward. Josh, anything to add before we take questions?
No, maybe just real quickly to emphasize the point of, we understand that you operate within PJM, so you don't have exclusive, particularly thinking about the transmission part of this, the ATT part of this. So obviously it's going to be really important to coordinate with PJM and the TOs on, what are the kind of opportunities for a win-win with a sandbox to test out ATTs. So that's just one, thinking through how you engage with the TOs, collaboratively finding those win-wins and then engaging with PJM on how this could enhance some of the work that's going on across the region is just something that I'd also kind of encourage you all, if you aren't already, to think about and are happy to help you work through that as well.
Great. Yeah, and that was what we had for you all today. Hopefully that was helpful. I wanted to mention too, we're working with a number of other jurisdictions to help them set up and implement sandboxes. So we expect to have even additional learnings going forward, specifically from some projects working with transmission owners. So this is something we're continuing to think actively about, and would love to stay in conversation with you all. But yeah, would love to welcome your questions at this time.
Thank you so much, Grace and Josh. Anyone have any questions for our LBNL team? Shannon.
Yes, thank you so much. I think really helpful overview. Wanted to learn a bit more about, I think one of the categories was regulatory, and you touched on kind of assessing whether the tool is appropriate, and wanted to learn if there were instances where maybe a regulatory barrier was jurisdictional, given that Maryland is a restructured state, and sort of just examples of where states might have used this tool to kind of think through those boundaries.
Good question. Maybe to start with, like, assessing whether a sandbox is the appropriate tool. The thing that's standing out to me is when we were doing a literature review for this research, there was some really interesting, there was an interesting research paper, which I'd be happy to share, that sort of had a flow chart to help assess whether a sandbox was the right tool for assessing your innovation barriers. And the thing that stood out to me there was sort of, you know, can you identify if there is a regulation or law or requirement that is the specific hindrance to innovation in a specific instance? Can you just get rid of that right away? Like, can you waive it, or could you change it or modify it without having to go through this whole period of trials and assessing different, you know, pilots, those kinds of things. So I think there are a lot of opportunities for, you know, being more expeditious in how you overcome barriers, but in a lot of cases, a sandbox is a very helpful tool. I think I understood the second part of your question, or maybe your question overall, to be like, how do you assess specifically barriers in a restructured state? And I think there are some interesting examples to draw on from abroad, where their focus has really been on waiving things like licensing requirements, or you know, kind of specific legal requirements for innovators. And it goes broader than just the Public Utility Commission or just the utility sector. So they're looking at working with multiple stakeholders and identifying kind of more broadly what needs to be waived. I don't know if that was super responsive. Josh, maybe I'll let you see if you have any other ideas.
No, I don't have any on the examples on the kind of regional or, you know, RTO level of like waiving regulations or prior orders. I will say in Massachusetts, we were working through a similar concept of, is there a way to set up a structure to waive prior commission orders that maybe are presenting a barrier? And there's one example, well, actually maybe two examples. One, I think actually in stealing from the Rio context in the UK, there's actually all sorts of EV and VPP providers that actually are able to set residential pricing and different tariffs. Just they can change the tariff for the customer the next day, as long as they operate within specific parameters, and they never charge more than the wholesale market price on average over, I believe it's a quarter. So thinking about, are there ways to provide kind of a safe, you know, the current regulations in Massachusetts would not allow for that, but are there ways to kind of provide a waiver of that to allow for that? There's another DPU order and potentially legal challenge with actually allowing vehicle to X in Massachusetts where there's a rooftop solar array on the home and they're trying to provide power back to the grid. It actually just is not allowed currently in Massachusetts. So there's the potential to actually waive that rule to allow for that to happen. There's some technical things that need to be worked out at what rate they're actually compensated at, and that was the reason for the rule. But just to give you two examples of potential waivers or adjustments to rules that have been contemplated, at least on the distribution side of things, that would potentially enable new innovations.
Great. If those examples help and point around kind of being expeditious about overcoming barriers, well taken, and would welcome any that kind of flow chart through that research. I would welcome that to share with the group. Thanks.
Do we have any other questions? Sophie.
Yes. Hi, Sophie from Maryland PSC. Thank you all for the presentation. Wait, just digging in on the waiver piece of this. When they're implementing waivers, does that tend to be like time limited from the outset, or is okay?
Yeah, and Grace, obviously, feel free to if you have anything to add here. My understanding is that waivers are usually time limited and also scope limited. So going back to the principles before, you don't want to distort markets or give one technology provider an advantage unnecessarily. But my understanding is it's usually scoped to, okay, this specific instance, you can try it, you can have a waiver of this specific rule for this amount of time. So kind of those three constraints are my understanding of the best practices around waivers.
Well, I'm excited to read.
Yeah, and then you would have, sorry, Sophie.
Oh, I'm just, yeah, go ahead.
I was just going to say, and think the important piece too is evaluating whether the waiver was successful and whether that should be continued for specific innovations or for like, a technology or a sector more broadly, so that you're sort of, okay, we identified this waiver was a barrier. Now we can remove it safely without, the risks that we thought might be associated with whatever we were waiving.
Understood. Thank you.
Okay, do we have any other questions? All right. Well, thank you both, Grace and Josh. This has been really wonderful. Being mindful of time, I guess I'll go ahead and wrap up with everyone. Thanks again to everyone that talked today. Very, very useful, very informative. What we did do today, right, listening to some presentations, we went over some newly enacted provisions in the Utility Relief Act related to ATTs and state planning and permitting. And of course, we just listened to some really useful information from Berkeley Lab and RAP about regulatory sandboxes for advanced grid technologies. And thank you again to Bob for stepping in from BGE earlier. We'll send this presentation and I think the LVNL presentation after the meeting. And we will also include a report from the Ohio Public Service Commission, which we were going to chat a little bit about today, but ended up not having time. Shannon might chat about that a little bit in our next session. And our next meeting is set for 11 a.m. Tuesday, June 16th. All right. Thank you, everyone. Have a good rest of the week.
Thank you.
Thank you.
Thank you.
Thank you very much.